What if I told you there's a sound that's tormenting thousands of people across the globe, a sound that science hasn't yet explained, and that according to the 1993 Taos study and follow-up surveys, roughly 98% of people can't hear? They call it the hum, a relentless, chest-rattling vibration. In media reports, it has been linked to nervous breakdowns, and in the most extreme cases, desperate acts of self-harm. For decades, the mystery has remained unsolved. But today, we're hunting for the truth. By the end of this video, we will reveal the most terrifying and plausible explanation for what the hum really is. The silence ends. For most, it's replaced by the familiar sounds of the world. But for a select few, it's replaced by something else. A question typed into the digital void, hoping someone, anyone, will answer. This isn't a new phenomenon. In the late 1970s, the Bristol hum became a local media obsession after nearly 800 people complained of a constant drone. The city's environmental health department investigated for years, ruling out power lines, gas mains, and local factory traffic. They found no cause. The hum continued, so if the sound wasn't coming from the city's infrastructure, where else could it be coming from? Across the Atlantic in the high desert of Taos, New Mexico, investigators would pursue that very question. Here, hearers described a complex mix of sounds, a hum, a buzz, and a whir. The phenomenon became so pronounced that in 1993 it prompted a formal inquiry by the United States Congress. A multidisciplinary team from Los Alamos and Sandia National Laboratories descended with sensitive equipment. Their final report was a bombshell of uncertainty. No single acoustic source, external or internal to the subjects, could be identified. And the map continues to light up. In early 2025, new reports emerged from the rugged Isle of Lewis. First reported in February, a Facebook support group quickly grew to over 200 residents, proving the hum is not a relic of the past, but an active and expanding modern mystery. These are not isolated pockets of delusion. They are data points in a disturbing global pattern. The Windsor Hum, so intense it triggered a formal diplomatic complaint. Reports in the area dropped by a documented 70% within 6 months of the 2020 shutdown of the nearby U.S. steel plant, providing strong evidence of an industrial link in at least one major case. But not every hum has an industrial source. In Largs, Scotland, investigators looked at everything: wind farms, naval activity, and the Hunterston B power station. All were officially ruled out in council-led acoustic surveys in 2015 and again in 2017. In Kokomo, Indiana, a city-funded study identified 2 industrial sources, but nearly a third of complainants insisted their hum persisted. The official study concluded it was likely that 2 distinct acoustic phenomena were at play, a theory later supported by University of Oklahoma researchers who suggested 2 different frequency bands were involved, hinting at overlapping sources. How could this be? Even in Bondi, one of Australia's most famous suburbs, reports of the hum persist, a modern mystery hiding in plain sight. And today, the acoustic ghosts linger. For a new generation of hearers, the experience is a form of audiological gaslighting leading to desperate measures, selling homes, moving towns, and spending fortunes on mitigation efforts that ultimately fail. For the hearer, the sound itself is only the beginning of the torment. The second is the grinding friction of not being believed. Isle of Lewis, Windsor, Largs, Bondi, Taos, Bristol. What single phenomenon could possibly connect them all? Or are we looking at different problems with the same name? To solve this puzzle, we must ask a series of critical questions. Is the hum man-made, or is it a product of the natural world? Is the source external, or is the answer hidden somewhere inside ourselves? Our investigation will test every angle, industrial, geological, and biological, to separate fact from fiction and find the acoustic ghosts rattling inside our own machine. But what makes this invisible sound so invasive? Unlike the sharp, quick wavelengths of everyday sound, the waves of LFN are incredibly long and powerful. It's the bass you feel from a car 2 blocks away. And at its lowest threshold, below 20 hertz, it becomes true infrasound, inaudible to most, but physically felt. Its energy allows it to travel for miles and pass through solid structures like brick and concrete with ease. This is why hearers report that there's no escape. The sound isn't just at their window, it's inside their home, vibrating in the very air they breathe. For some, this can even affect the vestibular system in the inner ear, creating feelings of nausea, dizziness, and disorientation, a constant low-grade vertigo. So where does all this noise come from? Our industrial landscape is saturated with it, the steady 50 or 60 hertz drone from a power grid that thousands of hearers describe, the pulsating thrum of massive diesel engines at pumping stations, the relentless moan of high-pressure gas being pushed through continental pipelines. All of them pump low-frequency sound into our environment 24 hours a day. For years, the clearest case for the industrial theory was the Windsor Hum. Its apparent resolution in 2020, when U.S. Steel idled its plant on Zug Island, serves as a textbook example of how industrial noise can, in fact, be the culprit. But this very success highlights the critical flaws in the theory as a universal explanation. First, if the Windsor Hum was solved by shutting down a factory, what about the hums in places like Taos or Largs, locations with no significant heavy industry to blame? There is simply no machine to point a finger at. And what about its strange behavior? Hearers consistently report the hum is worse at night and indoors. An industrial fan doesn't know what time it is. So why the change? And the biggest question remains the most profound, the problem of selectivity. Even in Windsor, directly across from the roaring industry of Zug Island, why did only a fraction of the population ever report hearing it? What makes their hearing so different? If a factory is making a sound, shouldn't everyone be able to hear it? So, while industrial noise is clearly a powerful piece of the puzzle, and sometimes the entire answer, it cannot be the master key for the global phenomenon. It fails to explain the cases where there are no machines, the strange behavior of the sound, and the select few who are afflicted by it. To find the next piece, investigators had to look away from the world we've built and toward the very ground beneath their feet. What if the sound isn't from a machine we built, but from the planet itself? A constant, powerful hum generated for billions of years before we ever existed. What if we're simply starting to notice the Earth's own voice? The most powerful voice on the planet comes from the ocean. When waves from distant storms travel towards each other, they can collide and create a standing wave, a fixed point of immense pressure that pulses down through the water column into the seabed and radiates across entire continents as seismic energy. Scientists call these powerful infrasonic waves microbaroms and microseisms. And this isn't a theory, it's a constant, measurable reality. The Comprehensive Nuclear Test Ban Treaty Organization, or CTBTO, operates a global network of infrasound monitoring stations. Their job is to listen for the signature of a secret nuclear test. But in doing so, they have created the most detailed recording of the Earth's natural planetary hum in history. It's a sound that many animals can likely perceive far better than we can. Their hearing often extends deep into the infrasound range. It's the suspected mechanism behind elephants' hearing weather fronts, whose calls can contain frequencies down to 14 hertz from hundreds of kilometers away. So, could it be this simple? Are human hearers just people with a latent hypersensitivity to the planet's own warning systems? And the ocean isn't the only natural source. When the volcano Krakatoa erupted in 1883, its infrasound wave was the loudest sound in recorded history, circling the globe nearly 4 times. The constant groan of shifting tectonic plates, the violent shock wave of a distant meteor, the subtle crackle of the aurora. Our planet is a cacophony of powerful, low-frequency noise. So the evidence is overwhelming. The planet is a massive source of low-frequency noise. The case seems closed, right? But then you listen to the hearers themselves. And here, the theory unravels. The planet's main voice is in the infrasound range, far below the frequencies most hearers report. The hum, conversely, is almost always described as having a tonal character, like a machine. The earth rumbles, it groans, it hisses. But does it drone? Does it hum with the steady, monotonous frequency of an idling engine? The natural world is powerful, but it's also chaotic. The sound tormenting hearers feels too structured, too consistent, too artificial, which led investigators down a much darker, more paranoid path. When conventional science fails, a vacuum is created. And into that vacuum rush unsettling questions about the technologies we can't see and the forces that might be operating just beyond our awareness. This path of the investigation leads us away from public science and into the clandestine world of military and intelligence operations. The first and most credible suspect in this world lies deep beneath the ocean. How do you communicate with a nuclear submarine? Normal radio waves are useless. They can't penetrate salt water. The solution was a technological marvel of brute force, very low frequency, or VLF, which operates between 3 and 30 kilohertz, and its even more powerful cousin, extremely low frequency, or ELF, which operates as low as 3 to 30 hertz. These are some of the most powerful radio transmitters on Earth. For decades, they bathed the planet in a low-frequency signal. The US ALF system, for instance, ran from 1989 until it was shut down in 2004. Yet, hum reports continued to emerge and even grow worldwide. This creates a major correlation gap. Still, many wonder, could the hum be an unintended echo of the VLF networks that still operate today? This line of inquiry inevitably leads to the holy grail of technological conspiracy theories, HAARP, the High Frequency Active Auroral Research Program. Officially, it's a scientific facility. In simple terms, its forest of antennas works like a focused radio wave blowtorch, operational only during short, publicly announced research campaigns like the one in May 2024 to temporarily heat a small patch of the ionosphere and study the effects. Critics, however, point to its immense power as evidence of a more clandestine purpose. Could such a powerful atmospheric weapon generate a persistent global hum as a side effect? These technologies are real, and their capabilities are unsettling. But as a definitive source for the hum, the theories collapse under scrutiny. The primary problem is correlation, and without a direct, verifiable link, without a single peer-reviewed study that has ever matched hum onset to VLF, ELF, or HAARP duty cycles, it remains where it began, in the realm of speculation. So where does that leave us? We've hunted for the culprit in our factories and found the theory incomplete. We've listened to the voice of the planet and found it doesn't match. We've peered into the world of secret technology and found only ghosts and speculation. For decades, this is where the investigation ended, in a series of frustrating dead ends. But what if the entire approach has been wrong? What if we've been searching for a single source, when the answer is far more complex and hiding in plain sight? What if the hum is not a sound that is projected, but an effect that is created at the point of perception? A new comprehensive theory suggests the answer isn't one thing, but a confluence of 3 layers, a perfect storm of physics and biology. The first layer is the signal floor. It begins with a baseline of noise we've all learned to ignore. Think of it as a form of acoustic smog, the constant low-frequency drone of our global infrastructure, not just factories, but the vibration of freight trains, the hum of massive server farms, the roar of continental power grids, all creating an ever-present acoustic floor. Next is the amplifier. This acoustic smog is usually too faint to notice, but under certain conditions, the environment itself can act as a massive lens. Geological basins can reflect and focus these sound waves. And crucially, atmospheric temperature inversions, common on still, clear nights when cool, dense air gets trapped beneath a lid of warmer air, can prevent the sound from dissipating, concentrating it dramatically in specific hotspots. This explains why so many hearers report the hum is worse at night. Finally, the most crucial piece of the puzzle, the receiver. Even this focused sound is often below the threshold of normal hearing. But a small percentage of the population appears to have a specific biological sensitivity. One leading theory involves spontaneous otoacoustic emissions, or SOAEs. This is a phenomenon where the cochlea, the hearing organ, is so active that it not only receives sound, but produces its own tiny sounds. For these individuals, the ear isn't just a microphone, it's a tiny biological amplifier, potentially creating a feedback loop that makes them uniquely tuned to perceive narrow, persistent frequencies that the rest of us filter out. Let's apply this theory to Taos, a case that baffled investigators for years. First, the signal floor, faint LFN from distant gas compressor stations. Next, the amplifier. The Taos Valley's unique basin geography captures and focuses these sounds. And finally, a population with a statistically significant number of sensitive receivers. In the original Taos study, the data confirms this. It was never one thing. It was a perfect storm. This explanation doesn't offer a cure. It provides something far more profound: validation. For the thousands of hearers around the world, it is proof that they are not crazy. They are not imagining things. They are simply sensitive instruments hearing the true, unfiltered sound of the world we have built. And with this understanding comes a new form of power: the ability to cope. Instead of searching for a single source to eliminate, hearers can now focus on managing their sonic environment. This includes using targeted sound masking, not just white noise, but pink or brown noise, which is richer in lower frequencies and more effective at covering the hum. It means understanding atmospheric conditions, knowing that a still, cold night might be difficult, and preparing for it. And most importantly, it means building communities. Armed with scientific validation, hearers are now organizing, sharing data with citizen science projects, and advocating for stricter, low-frequency noise ordinances. They are moving from suffering in isolation to managing their condition with knowledge and mutual support. We built a world of invisible forces to power our lives. We wrapped the globe in a network of machines we can no longer see. But the machine is not silent. It is screaming. The only difference is that, for now, most of us have the luxury of not being able to hear it. The only question left is, are you listening? The mystery of the hum is as much a human story as it is a scientific one. Now, we want to hear from you. Have you ever experienced a sound you couldn't explain? Or do you have a theory about what we've discussed today? Join the investigation in the comments. Your story and insight are a vital part of this global conversation. And if you believe that some mysteries are worth exploring, then subscribe and join us as we investigate our next global mysteries.